Okay, so what we're going to do is take this conductivity apparatus, okay? Basically, it's a light bulb connected to two electrodes down here. In order for electricity to be conducted through the electrode, we have to have a complete circuit. You may remember a little bit of that from some science class at some point in time. Currently, the electrodes are separated from each other, so there's nothing that's going to happen. I'm going to plug this in, and and nothing's going to happen. Now, I kind of chuckle. My last district, the two little plastic pieces that are covering up the electrodes, the metal electrodes, were kind of broken off, and the two pieces were just a smidge exposed. I've accidentally touched those two pieces at the same time, gotten a little something there. So yeah. So anyway, so the only way this thing's going to light up is if there are some charged particles, ions, for example, that are going to be present to conduct electricity. So far, so good? Okay. So the first thing I'm going to demonstrate is sodium chloride, table salt, which is the first thing we looked at, right? So I'm going to dump some sodium chloride in here, and then stick this thing in here. And since sodium chloride, as we know, is a strong electrolyte, we would expect this thing to do what?
Light up.
Light up. So here we go.
There's no water in there.
So?
It doesn't disassociate.
Very good. Has to be water to break those ions apart, right? Sodium chloride itself doesn't conduct electricity because all the ions are attached to each other. Okay? So, let's take a little bit of that sodium chloride. Oh, you know what? We have to have a control here. Here's what freaks kids out all the time. Here's this electrical device plugged into a socket. Is that freaking anybody out right now? Isn't that kind of funny? Okay. To find out, what's that water we've been using a lot in our labs? The ionized water. What does the ionized water not have in it?
Ions.
Therefore, would we expect the ionized water to conduct electricity? What's that again?
I said it wouldn't, but
Okay. We do not expect that the ionized water to conduct electricity. So we'll try to demonstrate that. Put this in here. Now, that ruins everything. Okay? I discovered something last period that actually worked. Can you see in there? Okay. Can you guys see now? Is the light bulb glowing?
no.
Why not? There's no ions available. Okay, excellent. So we can see that the ionized water has no ions. Pure water does not conduct electricity. So let's take a little bit of the sodium chloride and pour it in here and see what happens. Give it some swirls. By golly, what do we have? Conducting, and then there was light. Conducts electricity because it is a strong electrolyte. Okay. So we're going to find out that not only does the electrolytic property, whether they're strong, weak, or non-electrolytes, have anything to do with the extent to which it conducts electricity, it also depends on the concentration or how many ions are present. Okay. Remember I said earlier on that strong acids are also strong electrolytes? Okay. I want to demonstrate hydrochloric acid, which is a strong acid. Okay. this is hydrochloric acid. It's 0.1 molar. It's not very concentrated. You guys remember the molarity thing a little bit from the other earlier in the year, okay? 0.1 molar. Put that in there. What do we get? Strong electrolyte. The hydrochloric acid completely dissociates. But as I add some more water to this, I want you to look at the extent to which it glows. Anybody notice anything?
Looks like it got faint.
Did it get fainter, dimmer, more dim? Would you agree? So, even though hydrochloric acid is a strong electrolyte, it completely dissociates. It also depends on how much hydrochloric acid's in there relative to the solution. So the concentration also matters. Okay? Good, good. All right, so that's all fairly fun and easy to do. Next, I want to do a weak electrolyte. And of course, what was the example I gave you guys for a weak electrolyte? Acetic acid, otherwise known as vinegar. Okay. What have I here? Vinegar. And if you read the ingredients, it says, I can find the ingredients. Vinegar will dissolve pearls. Doesn't even say what it is. How about that? It's acetic acid. So here we go. Now, we're expecting this possibly to do what? Now that we have a little bit of knowledge about this. Weak electrolyte, therefore, partially dissociates. We just saw what happens with concentration and the amount of electricity it can conduct. The less concentrated, the less electricity, right? The less glowing. Oh, wait, is it glowing?
No.
Well, those of you that were really paying attention might say, well, it is a little bit, and that's where this room kind of is not good because of that light. I'm going to take this out. Watch carefully. Anyone see a difference or not?
Do it again.
I think you can see the difference better when I pull it out. Watch this.
Yeah.
Okay, now, hence the box. Can you guys see anything? What do you notice? Is it glowing? Just a little bit, okay? Remember that thing where I put up there with 0.8 times 10 to the negative fifth? We said it barely dissociated. There's evidence of that, okay? Here's the fun part. I always love it. Thank you, Todd, for providing us an opportunity here. Do they sell Gatorade in this building or not?
I don't know.
Because my other two periods probably won't have this. What is the whole point of Gatorade? You know what? I'll make some Gatorade. Here we go. I'm going to make some Gatorade. My bad.
Just looks to be stuff on it.
Hold on. I'm going to demonstrate a non-electrolyte right now. I'm going to take some sugar. I'm going to make some Gatorade. Here we go. Now, what do we expect about sucrose, sugar? non-electrolyte. So here we go, make up my little Gatorade here. There we go. Anybody up for some Gatorade? Well, you know what, it's not quite Gatorade. Hold
It's a
on.
salt maker.
Hold on. Here we go, Gatorade. Go ahead, here we go.
Are you serious?
Just sugar.
Do you actually drink that?
Sophomores. Anyway, why am I calling this Gatorade?
Water is always sugar.
Water and sugar. Please read the first three ingredients.
Water, sugar, dextrose.
What's dextrose? Sugar. First three ingredients, two of them are sugar. What's the point of drinking Gatorade?
Put sugars back in your body.
Electrolytes, which are, as we now know, salts. Find salt on here and tell me which ingredient it is numerically. Sixth ingredient. Two of the top three, sugar, the thing that you're drinking it for, number 6. Thank you, Todd. Oh, first of all, let's show the sugar water. What do we get? Which is what we were expecting, right? Non-electrolyte, sugar, doesn't dissociate. I'll even do this, kind of confirm. You guys agree? Is there anything there? Nope, can't be. Nothing there to dissolve or dissociate, sorry about that. No ions to dissociate. So, let's take a little of Todd's Gatorade.
Use as much as you need.
Pardon? And here we go. Ooh, did you see that? Did it dissociate very much? No. I mean,
Just a faint.
you guys see it? A little brighter than the vinegar, I think. Would you agree? But how much electrolytes in there? Yeah, remember, two of the top three ingredients, sugar. You're drinking Coke when you drink Gatorade. Or Kool-Aid, whichever one you want to call it. Doesn't really matter. Alright.
So what drink should you drink to replenish electrolytes?
Water,